This is section 261. We're going to be graphing two variable inequalities. And so we're going to be able to graph two variable inequalities. Now, when we graph two-dimensional inequalities, what's actually happening is we're no longer thinking of the linear number line. There's both an x and y. So we have to consider both of those number lines. And so because of that, we're going to be graphing on the xy coordinate plane. Now, instead of just this number line and then you have a value and then there's some shading, well, if we now have a two-dimensional space, that means the solution are going to be a bunch of points. And instead of just doing this, which the solution is a bunch of points, the solution is going to be a region of the graph that we shade in. So let's look at our first example. I have the graph y is less than x plus 3. Now we pretend it's an equal sign. So this is an equal sign. We're going to pretend it's an equal sign. So think of it as, y equals x plus 3. Okay, we look at the y-intercept. The y-intercept is 3, so I can put a dot at 3. And then I look at the slope. My slope is 1. And so therefore it goes up 1 over 1, up 1 over 1. And now I can go ahead and draw my line. Now if you remember, open circle was used for when we couldn't equal 2. But now it's not linear anymore. It's two-dimensional. So because it's two-dimensional, we have to symbolize that it can't equal it a different way. And so we are going to use a dashed line to symbolize when you can't equal it. So it's a solid line when you can. It's a dashed line when you can't. It's just saying the solution is not on the line itself. Then the question is, do I shade on this side or do I shade on this side? And so the way we figure it out is to test a region or test a value, plug it in and see if it's true or false. So for example, what if I picked 0, 0? So if I picked 0, 0, you take it, you plug it in, you see if it's true or false. And so in this instance, if I plugged in 0 for x and 0 for y, you get 0 is less than 3. That's a true statement. That means on this side of the line, which happens to be where that point is, that value is true. And so you shade the side that's true. That means that every single point that you pick in this region, no matter what point, it could be any point. If you took that point and you plug it into the equation, it'll be 100% true all the time. And so the shaded region is just the sum or the representation of all of those points on the region. Let's look at another one. This is x minus 2 squared plus 3. Okay, so now I have to think, what is my h? What is my k? And so this is a parabola, right? Because it says squared, so I know it's a parabola. Here's my horizontal shift. Here's my vertical shift. Normally it starts at 0, 0. And because of the horizontal shift, it's over 2. Because of the vertical shift, it's up 3. And so there's my parabola. Now notice it's solid because this is equal to. Now again, I have to pick a point to see where I need to shade. The question is, do I shade inside the parabola or do I shade on the outside of the parabola? Well, to figure that out, again, you pick a point and you test it if it's true or false. So if I picked 0, 0 again, 0, 0 if you're able to is the easiest one to pick. You plug it in and see if it's true or false. So I plugged in 0 for x, I plugged in 0 for y. When we simplify it, you're going to get 0 is less than or equal to 7, which is true. Now that means everything on this side of the parabola, which is on that side of the region, all of that is true. And so you shade it in. So to conclude today's lesson, what did we learn today? We talked about how to graph two-dimensional inequalities. And so you graph it like normal. So you do your H or K, or if it's a line, it could be a square root, it could be whatever graph. You graph it, and then you have to test a value. You plug it in to see if it's true or false. And that'll determine what region you shade. This does conclude our lesson. If you have any other questions, please leave them in the comments.